Hi guys, and welcome to our second notes of this Unit 8. Okay, so right now we're doing Unit 8, Notes 1-2. Okay, so we're going to first do a little bit of reviewing of that prime factorization because it is so important. Now, some of the mistakes I noticed that you guys were making yesterday is that you weren't simplifying fully. I saw a lot of students leaving like 8 and 4 or something like that. You need to make sure that the ends of each of your tree have prime numbers. So let's take a look at 95. So for 95, I see that 5 there. Okay, whenever I see a 5 or a 0 at the end, I know that it's divisible by 5. So I take 95 and divide by 5 and I get 19. So I find out that 95 has 5 and 19. So then I know that 5 is a prime number, and I think about 19. Well, 19 can only be divided by 1 in itself, so 19 is also a prime number. So these are both prime numbers. So then I'm going to write them out. Again, you want to be writing them out in numerical order. So I have 5 times 19. Next, let's take a look at 36. Well, thinking back to when you guys made that perfect square list yesterday, you guys remember that 36 is a perfect square. Okay, so we can actually take and we can write this as 6 and 6. Remember, perfect square is anything that can be multiplied by itself. So if we were to take the square root of 36, we would get a whole rational number. Okay, so let's take a look at splitting up that 6. So we have 2 and 3 for that 6 and 2 and 3 here. So we're going to look at the ends of our tree and we're going to put it in numerical order. So we have 2 times 2 times 3 times 3, and that is your prime factorization. So we're going to leave that there. Lastly, I want you to take a look at number 3. I want you guys to go ahead and do that one on your own. So see if you can split up 72. If you're stuck, notice that 72 is an even number. So worst case scenario, you can just divide by 2. Okay? Alrighty, next. Okay, so this is going to be a lot of writing involved. So again, this is a time where you really need to pause the video because I am going to be checking that you have this in complete form. So write it all down. Okay, so a radical expression is any expression with a radical term. That's a little square root symbol. Now, most of the time it is a square root. We're not going to really be dealing with when the radical is not a square root. So you can just safely assume that we're dealing with square roots. But the symbol that we sometimes call square root, the actual mathematical term for it is a radical. Okay, so a radical expression is anything that's going to have that radical in it. Okay, this right here, if you look, this guy right here is the radical symbol. Okay. Now, what is a simplified form of a radical expression? So you want to pause your video, make sure you can get this all written down. Okay, so the simplified form is that there's no perfect squares underneath the radical. Now remember, perfect squares are anything where the square root is rational. So 36 was 1, 25, 9, 49, okay? Things that you could take the square root of that they have a pair multiplying to that number. All right, you also don't want to have fractions underneath the radical. All right, so you want to get rid of any fractions. We're going to be dealing with that more next week. All right, and lastly, you want to have no radicals in the denominator of the fraction. This one's going to be huge, and we're going to be working a lot with that coming up in the next couple of weeks. But you really don't want to have a radical in the bottom. It's kind of a math no-no. So again, make sure you have this entire chart written out. Next, let's kind of talk about what these look like. Okay, so the product property says that we can take two radicals and we can multiply them together, okay, and then we could also separate them and we can multiply that together. So let's take a look at what that would look like. So for example, we're going to write down an example here. So yes, square root of AB is equal to the square root of A times the square root of B. So for example, if we had the square root of 10, for example, well, I know that two things that multiply to 10 are 5 and 2. So the square root of 10 is the same as the square root of 5 times the square root of 2. Okay, those two are equal. We could write them either way. Quotient property is the same kind of thing. If we're dividing underneath the radical, we can split that into two division symbols. So for example, if we had the square root of 20, that could also be written as the square root of 40 divided by the square root of 2. Notice that 40 divided by 2 is 20. So we can go ahead and we could split those up if we want. Okay, and then we're going to be using this to simplify a lot of terms. And here's the biggest thing, probably the most important idea we're going to be using towards the end of this unit, is that if you square a square root, you get whatever's left underneath. So for example, in this I heart math, if we were to take the square of the square root of a heart, we would just have a heart left. Okay, so for example, let's say we had the square root of 2. And we're going to go ahead and we're going to square the square root of 2. Okay, squaring undoes a square. I'm going to say that again. Squaring undoes a square. So when we have the square root risen to a squared, then we're just going to take what is underneath the radical. So this is just equal to 2. Okay, so don't make that more complicated than it is. All you're doing is looking underneath that radical. All right, let's take a look at how some of these are going to be simplified. Okay, so we're going to be using a combination of what we learned yesterday as well as a little bit of the radical properties that we learned. The biggest thing that we're going to learn is that you could take the product of two radicals and separate them out, and the fact that the square root squared is just that number. So let's take a look at 50. So the first thing I want to do with 50 is I want to break it down entirely into primes, just as we did yesterday. Well, I'm thinking about 50, and I know I can do 25 and 2. Likewise, 25 can be broken down to 5 and 5. So I'm going to go ahead and I'm going to write my radical symbol, and then I'm going to put the ends of my trees underneath the radical, and we can multiply it all together. So we're going to take the first and then multiply the next 2. So we have 2 times 5 times 5 underneath the radical. The next thing we're going to do is we are going to go square, I call it pair hunting. Okay, so you cannot leave this radical jail unless you have a partner in crime. Okay, so you can't come out from underneath the radical unless you have a partner. So let's take a look. Where do we have partners? Well, I see that I have 2 5s here. So that means I can pull that 5 out of the radical. That 5 has a pair. Okay, so it's going to come outside of the radical. So on the outside of the radical, I'm going to write that as 5 times the square root of 2. So those are actually being multiplied. So this right here, and this right here are all equal. Okay, so we're putting all of those together, all right? I'm sorry, we're simplifying it. And so our end result is the same as each of those. Okay, let's take a look at 48. We're going to do the same thing. We're going to start by doing the prime factorization. So I know that 6 and 8 go into 48. And for 6, I have 2 and 3. For 8, I have 4 and 2. I'm not done here. A lot of you guys stopped at 4 yesterday. Remember, 4 can be broken down to 2 and 2. So the next thing we want to do is we want to write out our prime factorization underneath that radical. Okay, so I'm going to write my radical symbol, and then I'm going to pull the ends of my trees, and I'm going to put it in numerical order. So I have 2 times 2 times 2 times 2 times 3. Okay, now again, I want to go pair hunting. So that's what I'm going to do. I'm going to circle my pairs. I actually have 2 pairs of 2s, and I'm going to bring them to the outside. Now, when we bring things to the outside of the radical, it has to have a partner, and anything outside of the radical is being multiplied. So we pull out that 2, and then we're going to pull out another 2, so that's all being multiplied, and that's multiplied by the square root of 3. So the last thing we need to do before this is fully simplified is take 2 times 2, which is 4, and then radical 3. Next, let's take a look at the square root of 32. Well, you did this one a little bit yesterday on your worksheet, actually twice if you were paying attention. Okay, so I'm going to break down 32 into 16 and 2. So then I know 16 can be broken down to 4 and 4, which can be broken down to 2 and 2, and likewise 2 and 2. Okay, so what we're going to do now is, again, I'm going to write all of that out underneath the radical. Okay, so I have my radical symbol here, and now I'm going to write out the ends of each of my tree. And don't forget that guy way up there. Okay, you want to go to the end of each of the legs, and you need to make sure that all of that is underneath the radical. So we have 2 times 2 times 2 times 2 times 2. And now we want to pull out any pairs we might have. So we could pull out this pair, and we can pull out this pair. And again, we're going to multiply those 2 on the outside, and then whatever doesn't have a pair is left underneath the radical being multiplied. 2 times 2 is 4. So for this one, we have 4 times the square root of 2. Okay, let's take a look at some more here. Let's take a look at number 4. Okay, so for number 4, 125, if you don't know what divides 125, go ahead and play around on your calculator a little bit. But 125 can be split into 25 and 5. So I'm going to go ahead and I'm going to break down 25 just a little bit more. So I'm going to break that down into 5 and 5. So then underneath the radical, I'm going to have 5 times 5 times 5. And then last but not least, I'm going to go ahead and I want to pull out some pairs. So I have a pair of 5s, so that's going to come to the outside, and I have 5 radical 5. Okay, let's take a look at 80. So 80, I see that there's a 0 here. That 0 tells me that I can divide out a 10. So that's exactly what I'm going to do. I have 10 and 8 going to 80. And remember, you want to break down each of these as much as possible. So 5 times 2. Keep dividing until you can't divide anymore. That means you have all primes. So I'm going to the end of each of my legs. Okay, so then I have the square root, I'm going to write it in numerical order, of 2 times 2 times 2 times 2 times 5. Again, I want to go ahead and I am going to pick my pairs. So I have a pair of 2s and another pair of 2s. So I'm going to bring those out to the outside. Okay, so I bring those out. I have 2 times 2 times the square root of 5, and that's equal to 4 times the square root of 5. I'm going to leave number 6 up to you guys to try. Okay. Next, let's take a look at number 7. So for number 7, we have, oops, went too far. So for number 7, we have an interesting scenario, okay? We talked about perfect squares yesterday. So if you can recognize those perfect squares, this problem will take you a lot less time. Okay, I look at that and I say, hey, that is the square root of 100 is 10. So if you recognize that as a perfect square, you can just say, bam, that's 10, I'm done. Okay, if you recognize that that is a perfect square. Let's say you don't. So we're going to go back to what we normally do. We take 100, and I know, okay, well, that's 10 and 10. That's 5 and 2. That's 5 and 2. So you write that out underneath the radical, and you have 2 times 2 times 5 times 5. So we end up having two pairs that we can pull outside of the radical. So then we end up getting 2 times 5, which is 10. Okay, both lead you to that answer. Okay, both lead you to that answer. Let's take a look at 75. Okay, again, you could go with the fact that it's a 5. You could divide it by 5, see how that way goes. I look at 75 and I think, hey, that is divisible by 25. So I'm going to write this as 25 and 3. Okay, one way to help yourself is to see if there's a perfect square that goes into the radical. So you made that list of perfect squares on your notes yesterday, and that helps a lot too. So we're going to go ahead and we're going to split up that 25. We're going to split it into 5 and 5. So then we're going to write underneath our radical what we have left. So 3 times 5 times 5. And then we're going to go ahead and we're going to pull out our perfect squares out from underneath the radical. So I have a pair of 5s, that's going to come out, and I'm left with 5 times the square root of 3. I want you guys to go ahead and try number 9 on your own. Oops, keep doing that. I also want you to go ahead and I want you to try doing number 10 on your own. I will give you a hint and tell you that number 10 is very, very, very similar to number 7 in the way that you do this. So let's go ahead and take a look at number 11, and then I'm going to have you do number 12. I'm at least going to get you started on number 11. So this is a big number. Okay, so I just start playing around. I'm like, I don't know what goes into this. You could try 2. I'm like, okay, you know what? I'm just going to try 4. So I took 384 and I divided it by 4. And then I was left with 4 and 96. Well, 4 I can break down to 2 and 2. 96 I still got to break down. So I said, okay, can I divide 96 by 4? And I can. So I made that 4 and 24. And then 4 I broke down to 2 and 2. 24 I broke down to 6 and 4. 6 I can break down to 2 and 3. 4 I can break down to 2 and 2. So underneath my radical, I have 2 times 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 3. Okay, so I want you to write that down. I want you to circle all those pairs and pull out the pairs, and we'll talk about this one in class together tomorrow. And then last but not least, I want you to try number 12 on your own. We will talk about all of these in the future here. So good luck. Show me your worksheet once you're done, and you can get going on your homework.